Hello everybody, welcome into another lesson. Today we are going to talk about variables and expressions. So yesterday we dealt exclusively with numbers and expressions. Well, today we're going to talk about variables. So we're going to solve some variable equations. And we have the type of variable equations today that they already give you the value of x, the value of y, and the value of z. You just got to stick those numbers in wherever you see those variables. Then we're also going to do a few minor word problems like we did yesterday, forming a sentence out of words to make it a variable equation. So let's get started here with our first problem. We're going to evaluate the expression of z plus 2. So you're given z plus 2. Evaluate each expression if x equals 7, y equals 3, and z equals 9. Well, you have no x, you have no y, but you have a z. So all you would have to do is stick in the 9 for z, wherever you see the z at. You would get 9 plus 2. The answer would be 11. So basically these type of variable equations are just plug and play. That's really all it would come down to, is plug and play. Pretty simple, huh? How about if we got 2 plus 4z? 2 plus 4z, you got to evaluate that. Well, again, you're going to put the 9 in for the z, so what you would have is 2 plus 4, that's 4 times z, so that'd be 4 times 9. You'd have 2 plus 4 times 9. Well, order of operations states that we do the multiplication first, so you'd have 2 plus 36, because 4 times 9 is 36, which would give you 38. So 38 would be your answer for this equation of 2 plus 4z. Alright, well, we've done a lot of z's. How about if we have 6y over z? So they give you 6y over z. Well, again, you're going to stick in, wherever you see the y, you'll stick in 3, because y equals 3, so you would have 6 times 3 over the z, which z equals 9. So you'd have 6 times 3 over 9. Which 6 times 3 in the numerator, that's 18. You would have 18 over 9, which 18 divided by 9 is, well, 2. So the answer to this equation would be 2. Basically, it's just a matter of plug and play. What do we got here? Alright, how about 10 minus xz over 9. So you'd have 10 minus xz over 9. Well, that's going to be equal to 10 minus, well, x equals 7, this tells us. So you'll have minus 7 times z, which is 9, all over 9. Well, we have 10 minus 7 times 9 over 9. Well, we notice in the second part of this expression here, in the second term, you have 9s that will cancel out from numerator to denominator, so all you'll be left with is 10 minus 7, which would give you an answer of 3. You did not even have to do the multiplication to know you got 9s that'll cancel out. You reduce it down to 10 minus 7, you get 3. So basically just a matter of sticking these variables in. When they tell you x equals 7, y equals 3, and z equals 9, wherever you see any of those variables, you stick them in. Alright, how about this one? 2x plus 3z plus 5y. Alright, so you're asked to evaluate the expression of 2x plus 3z plus 5y. Well, we know x equals 7, so we'll stick in the 7 where x is, that would be 2 times 7 plus, you'd have 3 times z. Z is 9, so you'd have 3 times 9 if you stick that in for z, plus 5 times y. The value of y is 3. So first you're going to do all your multiplication. 2 times 7, well, that's 14. Plus 3 times 9, well, that's 27. Plus 5 times 3, well, that's just going to be 15. Now you just have a simple addition problem. So let's start with 14 plus 21. That'd be 41 plus 15, which 41 plus 15, well, that would equal 56. So your answer you would get would be 56. Just stick in the values where you see the variables at. Let's do another one like it. Let's do 5z minus 3x minus 2y. So we have 5z minus 3x minus 2y, okay? Again, we see in the first term we have 5z, so you'd stick 9 in for z. You would have 5 times 9 minus the 3 times the value of x. Well, x equals 7. You would stick 7 in for x. You'd have 3 times 7 minus 2 times stick in the value of y, which is 3. And then you would have a nice order of operations equation. Well, of course, you're going to do all your multiplication first. 5 times 9, that's 45. Minus, now what's 3 times 7? That's 21. Minus 2 times 3, which is 6. Now you have a simple subtraction problem. Well, 45 minus 21, that's going to be 24. Minus 6. 24 minus 6, that's going to be 18. So the answer to all this would be 18. So yes, just stick it in and plug and play. That's really all these are, honestly, when it comes to evaluating expressions. Whenever you have variable expressions and they tell you what the variables are, what they equal, all you got to do is stick in the numbers that it equals for wherever you see the variables, and you just have a simple math equation. Okay, now on to a little bit of word problems, as we were talking about. Not really problems per se, but we want to translate this into an algebraic expression, okay? Say you're given Bianca's salary plus a $200 bonus. Okay, so what the goal is here is to take this statement in English, this sentence, and translate it into an equation with a variable. Bianca's salary plus $200. Well, the salary is the variable because we don't know what her salary is. We know the $200 bonus, but we don't know what her actual salary is. So whenever you're trying to define a variable, what you want to use is called a let statement. And if you've been with me since basic math, we've used some let statements. So this will be a little bit of a review. We'll say pick an appropriate variable, just don't pick E or I. E and I actually have numerical values that we're not going to get into in this course. That won't be till Algebra 2, but they do have actual numerical values, so let's not use E or I. But I think S, let S equal Bianca's salary. But yeah, you can pretty much pick whatever variable you want, honestly, just not E or I. But let S equal Bianca's salary. Okay, so they're saying she has her salary plus a $200 bonus, so what you would have is s plus 200. That would be the expression, the s being Bianca's salary plus 200. It would just translate into s plus 200. So there's that one. Let's do a few more word problems here. Do a few more expressions. Okay. How about this one? 3 more than the number of cakes baked. So this expression, they tell you you have 3 more than the number of cakes baked, right? Well, we don't know the number of cakes. We really don't know how many cakes are baked. So you're going to have a variable based on the number of cakes baked. So we want to use a let statement. We want to pick an appropriate variable. It could be anything except for E or I again. Just don't use those two when you're doing variables. But you could pick anything you want for a variable letter-wise. I'm going to say let C equal number of cakes baked. We'll say C will be the number of cakes baked, right? So you have C, and then they said 3 more than the number of cakes baked. Well, if we remember from yesterday's lesson, more means plus. 3 more, so that'd be C plus 3. That's 3 more plus 3. So your answer for this would be C plus 3. Because you have C, the number of cakes baked, and they said 3 more than the number of cakes baked, so C plus 3. That's what that would translate into. Okay. How about we got 6 feet shorter than the mountain's height. Okay. We got 6 feet shorter than the mountain's height. Well, again, we don't know what the mountain's height is, so that's going to be the variable. The variable always represents an unknown in any expression. That's what a variable is. So we need to form a let statement. Choose an appropriate variable. I'm going to say let M equal the mountain's height. M will equal the mountain's height. That'll be our variable. Alright? So we have 6 feet shorter. That means minus 6. Shorter than the mountain's height. So basically you're going to have the mountain's height minus 6 feet. Because it's 6 feet shorter than the mountain's height. So you have the mountain's height, take 6 feet away, you would have the height of whatever you're trying to figure out. So the answer to this expression would be m minus 6. That would be an algebraic expression for that. It would be m minus 6. Alright. What's next? 2 seconds slower than Joseph's time. So we have 2 seconds slower than Joseph's time. Well, we don't know Joseph's time, so that'll be the variable. Pick a variable, use a let statement. We'll say let j equal Joseph's time. I think that would be a good variable as j. So let j equal Joseph's time. So we have 2 seconds slower than Joseph's time. So slower is going to be j. Now if it's slower, it took 2 seconds longer. That's where they trick you, because slower means it actually took them longer. You're actually adding time if it's slower. If it were faster, you'd be subtracting time. So it's going to be Joseph's time plus 2 seconds, because whatever this is, it took 2 seconds longer than Joseph's time. It was slower. So your answer is going to be j plus 2. Yeah, slower means it took more time, where if it were 2 seconds faster than Joseph's time, you'd be taking away 2 seconds. So whoever this is, or whatever they're competing against, the expression for that would be j plus 2. Because you have Joseph's time plus 2 seconds because it was slower than his time. Alright. Let's do a couple more here. We have 2 more examples. Let's see. We have 3 times as many balloons. We have 3 times as many balloons. Well, we don't know the number of balloons, right? We certainly don't. So that's going to be your variable. I would say let b equal the number of balloons. That would be a good variable. Let's let b equal the number of balloons. Now, they said 3 times as many balloons. Well, that should be a dead giveaway. That's going to be a multiplication problem. 3 times. So you will take 3 times as many balloons. That'll just be 3 times the number of balloons. So the answer you would get is 3b. That'd be your algebraic expression. That's literally 3 times as many balloons. 3 times the number of balloons. So I think that one was a dead giveaway, that it was a multiplication problem. Now this one may not be as obvious. This one's probably not as obvious here, but a good thing we're teaching it. The product of 12 and a number. So we got the product of 12 and a number. Well, we don't know what that number is, so that'll be the variable. So we'll let n equal number. N will equal the number. Alright, so we've defined our variable. That's great. Now, what's the product of 12 and a number? The product means multiplication. So if you see the term product, that also means multiplication. So the product of 12 and a number is just going to be 12 times that number. It would be 12n. And that would be an algebraic expression. It's the product of 12 and a number, just 12 times that number. It would just be 12n. So really it comes down to, again, understanding what it is they're asking you, what it is they're trying to tell you when you go to solve these equations. So that's about all I have for this lesson. The next lesson we will be talking about properties of addition and multiplication, and even a little bit of deductive reasoning. So I hope everybody has a good night, and take care.